Imagine an object hurtling through our solar system from the depths of interstellar space, defying our expectations in ways that challenge everything we know about comets and asteroids. That's the story of 3I Atlas, and it's got scientists and armchair astronomers buzzing with excitement and debate. But here's where it gets controversial. What if this isn't just a cosmic wanderer, but something engineered by an intelligent civilization? Stick around as we dive into the latest data that's fueling this wild speculation. Fresh insights from the Minor Planet Center and NASA's Jet Propulsion Laboratory have just been unveiled for the interstellar visitor known as 3I Atlas, right after its closest approach to the Sun, called Perihelion, on October 29, 2025. These new observations span from October 31st to November 4th, offering a tantalizing glimpse into its behavior. Compared to earlier readings from October 5th to 8th, 3I Atlas has dramatically brightened, shining about 5 times more intensely in the green band of light, which peaks at a wavelength of 0.464 micrometers. For beginners, think of this as the object glowing much brighter in a specific shade of green-blue light that telescopes can detect, hinting at changes on its surface or in its surroundings. And this is the part most people miss. The object's non-gravitational acceleration, a push beyond just gravity, has dropped to about 2/3 of its previous value from October 29th. Importantly, this shift fits within the margin of error, and now the detection is rock solid at 3.7 standard deviations, meaning we're confident it's not a fluke. This acceleration was measured at a distance of 1.38 times the Earth-Sun separation. That's about 206 million kilometers from the Sun, and it acts only within the plane of 3I Atlas's orbit, without any vertical component. To break it down for those new to astronomy, non-gravitational acceleration occurs when an object's motion is influenced by forces other than gravity, like gas escaping from its surface. Here, it's described mathematically, following an inverse square law, meaning it weakens with the square of the distance from the Sun. The components at a standard distance of 1 astronomical unit, AU, are radial acceleration away from the Sun of 1.1 times 10 to the power of -6 AU per day squared, and a transverse one, sideways relative to the Sun's pole, of 3.7 times 10 to the power of -7 AU per day squared. Imagine a comet speeding up not just because of the Sun's gravity, but as if it's being nudged by its own outgassing, like a tiny rocket thrust. Drawing from principles of momentum conservation, as explored in related discussions, it's clear that 3I Atlas must have shed a noticeable portion of its mass to achieve this acceleration via what's known as the rocket effect. In simpler terms, when gas shoots out from the object's surface, it pushes the object in the opposite direction, much like a spaceship's engine. The mass lost can be calculated as the time of perihelion passage, multiplied by the acceleration, divided by the gas ejection speed. Perihelion passage lasted about a month, based on a distance of 203 million kilometers, divided by a speed of 68 kilometers per second, and the acceleration equates to 94 kilometers per day squared at that point. Putting it all together, this suggests 3I Atlas lost roughly 13% of its mass, divided by the ejection speed in units of 300 meters per second. For context, 300 meters per second is typical for gas molecules escaping a comet heated by the Sun, a natural limit for icy bodies. So, if it's a regular comet, it would have needed to evaporate more than 13% of itself. But what if it's powered by advanced technology? A rocket engine could eject gas at supersonic speeds, meaning far less mass loss would suffice. This ties into its sudden brightening and bluish hue near perihelion, which could stem from natural cometary activity and carbon monoxide ion emissions, or perhaps from a high-tech engine with minimal mass sacrifice. But here's where it gets controversial. Is 3I Atlas a natural comet or an alien probe? This stark contrast sets up a decisive test in the weeks ahead. If it's a typical comet, it should now be enveloped in a vast gas cloud containing at least 13% of its original mass, far more than the faint presence observed from July to September, when no non-gravitational acceleration was detected from over 4,000 data points across 227 observatories. Spectroscopic analysis by the Webb Space Telescope in December could reveal the internal composition, peeling back layers beyond the surface. Yet, if no such massive cloud appears post-perihelion, the acceleration must stem from something else entirely, like artificial propulsion. The mysteries surrounding 3I Atlas don't stop there. Let's list out the anomalies that have researchers scratching their heads, each with odds so low they're raising eyebrows. Its backward, retrograde path aligns almost perfectly with the solar system's ecliptic plane, within just 5 degrees, a chance event with only a 0.2% probability. In July and August 2025, it sported a sunward jet, unlike the familiar tails of comets, confirmed not to be a visual trick. Its core is 1,000,000 times heavier than Oumuamua and 1,000 times heavier than Borisov. Yet it zips faster than both, with combined odds below 0.1%. Its timing was precisely tuned for close brushes with Mars, Venus, and Jupiter, while staying hidden from Earth at perihelion, a 0.005% likelihood. Its gas plume boasts way more nickel than iron, mimicking industrial alloys, with nickel to cyanide levels vastly exceeding all known comets, including Borisov, odds under 1%. Water makes up just 4% of its plume by mass, unlike the water-rich comets we're familiar with. It exhibits extreme negative polarization, unheard of in comets like Borisov, with odds below 1%. It originated from the same direction as the famous 1977 WOW signal, aligning within 9 degrees, a 0.6% probability. Near perihelion, it brightened faster than any comet on record and shone bluer than the sun itself. Its non-gravitational acceleration implies evaporating about 1/6 of its mass, yet early images post-perihelion show no signs of this yet. These quirks collectively point to something extraordinary, sparking debates. Could this be evidence of extraterrestrial technology, or are we overlooking natural explanations? What do you think? Artifact or anomaly? Share your thoughts in the comments. I'd love to hear agreements, disagreements, or fresh perspectives. This morning, an email from Australia caught my eye, offering a thoughtful take on the broader implications. Dear Professor Loeb, I've been thoroughly enjoying your articles on 3I Atlas. While I'm not here to discuss its anomalies, which I'm sure you're fielding plenty of messages about, I'm reaching out to express my full support for your stance on the current landscape of scientific inquiry. As someone outside astronomy and physics, delving into managerial decision-making with soft computing, I still find myself captivated by cross-disciplinary science, including this interstellar enigma. From what I grasp of the theories, your approach strikes me as a courageous leap beyond the restrictive boundaries that modern science often imposes. These barriers, I believe, aren't always driven by the collective wisdom of the global scientific community, but by influential groups with vested interests that go beyond pure intellect. In my forthcoming book, Brainmaker, The Coevolution of Human and Synthetic Intelligence, I draw parallels between today's scientific power lobbies and the medieval church. History shows how figures like Galileo faced persecution for ideas that later proved true, clashing with ecclesiastical dogma. It worries me that science is morphing into a kind of organized religion, with these lobbies acting like ancient high priesthoods. Dissenting views outside the mainstream are met with fierce resistance, now intellectual rather than physical, through tactics like personal attacks, misrepresentation, and ostracism. Your ability to counter these challenges with composure and solid arguments is truly admirable. Though I don't claim to match your expertise, it would be an honor to correspond and exchange ideas on this troubling trend and its consequences for humanity's future. Thank you for taking the time to read this amidst your busy schedule. I'd be thrilled for a reply. Sincerely, Sukanto, a great friend of Avia, Dr. Sukanto Bhattacharya, Deakin University, Victoria 3220. About the author, Avi Loeb leads the Galileo Project, founded the Black Hole Initiative at Harvard, directs the Institute for Theory and Computation at the Harvard-Smithsonian Center for Astrophysics, and previously chaired Harvard's Astronomy Department from 2011 to 2020. He served on the President's Council of Advisors on Science and Technology, and chaired the National Academy's Board on Physics and Astronomy. Loeb authored the bestseller Extraterrestrial, The First Sign of Intelligent Life Beyond Earth, and co-authored Life in the Cosmos, both in 2021, with his latest paperback, Interstellar, released in August 2024.